Two ways to measure a process produce two different numbers. The ensemble average freezes time and looks across many paths at once. The time average follows one path and accumulates over time. For a multiplicative wealth process, these two measurements diverge. The ensemble can grow while the typical path shrinks. Maximizing the ensemble average is not the same objective as surviving on a single path. Expected value maximization targets the largest average increment across all futures. For a population of independent bets, this is a valid and coherent objective. But a single investor lives one trajectory, not the population average. Increasing drift raises the expected value but does not close the absorption barrier. The barrier is a property of the dynamics, not of the expectation. Ruin is a path-level event. The expected value does not govern it. The time average growth rate is a function of the bet fraction. It rises, reaches a peak, then collapses as the fraction increases beyond a critical value. That critical value is the Kelly fraction. The Kelly fraction is the unique fixed point that maximizes long-run growth on a single path. Betting above it introduces a destabilizing force. The growth rate turns negative. The system crosses from stable accumulation into structural contraction. In an ergodic system, running one path long enough gives the same result as averaging across many paths. Wealth under multiplicative dynamics is not ergodic. A few paths that multiply rapidly dominate the ensemble average. The majority of individual paths converge toward zero over time. The population statistic and the individual outcome are governed by different update rules. Optimizing for the population does not optimize for the path. A strategy that bets above Kelly can outperform in the short run. Expected value is higher. Some paths grow faster for a period. But the time average growth rate is negative. The system is contracting on average across time. The absorption barrier is absorbing. Once a path reaches it, there is no exit. Long-run collapse is not a possibility. It is a structural consequence of the negative growth rate. Overbetting cannot be rescued by favorable realizations. The expected value objective and the log optimal objective are different functions with different maximizers. Expected wealth maximization is indifferent to volatility. It selects maximum drift. Log wealth maximization accounts for the drag that volatility imposes on a multiplicative path. The Kelly fraction emerges from the log optimal objective, not the expected value objective. Neither objective implies the other. A system optimized for expected value can destroy its own time average growth rate.